Okay, so we are live. Yeah. Okay, so we are going to keep going on with KNN strategy part 3. Okay, well, as I said in the last video, what we need to debug today is filter and okay, small right here. Questions are welcome. And let's put this on the other one too, YouTube. Okay, so so let me show you where the hell is this. So here we have two different scripts. The one on the top, if I'm not mistaken, is the old code, which is what lastguru did here on wait a minute, I need this is what lastguru did originally. So this is a script with arrays, and it has a lot of functions in the same script, and it has a nice backtest here. And so he did a library out of this. Okay, so this is the library, and this library is meant to replace all of the functions that were in this original script. So all of these functions, now you are supposed to just use do KNN, and then all of the data that needs to be used, it's here inside of the library, thanks to this matrix of floats, thanks to this float matrix. Okay, so yeah, so that's what I'm doing here, is trying to understand why I don't have the same results. So as you can see here, we are checking the old code, and you have this result. Wait, this was not supposed to be here. And if you use the, and if you use the new code, it's a completely different result, even if I have modified both of the scripts so that they have the same behavior. As you can see, I have debugged everything thanks to some labels, and the matrix content is the same thing. Unfortunately, the advice that the wrapper gives us is not the same one as the original script did. So this is what I want to fix, to debug, so this improved script is the new code, which uses the library, and the one which is named old code, it's the old code without the library. So first of all, what we want to debug is the filter. So the filter in the library should be wait a moment, the filter. So the filter is here, you can see it here. Okay, so the idea is to just try to capture it so that we can check its value. So what I'm going to do here is filter. Well, I'm not sure what the hell is this. KNN sum. Is this array sum? So this is a float, because this is sum of floats, I guess. So this is a float. So this is 0, 0. And then what you actually do is, once you get this filter here, I don't care about the filter for %, although yeah, I'm going to copy and paste this so that later on, if I debug this, this is going to be right. Okay, so this filter, I'm going to return it. Just we didn't have enough variables, but now I'm going to return this. So on the bottom buffer, I'm going to open the same file, but down here. So whenever I call, what should I put in? I don't give investment advice, and you should not listen to anybody in the internet who gives you advice. Fudget. What the hell is a fudget? Oh my god. Okay, so what is this stream for? There is a description. Let me copy and paste the description for you. Where the hell I am? No, okay. Okay then. Yeah, okay, so this filter value is going to... I'm 12, therefore I am troll and hate people. I'm not sure you can have a TradingView user with 12 years old. Hopefully it's not true, because you don't want the account to be banned. Okay, so this value, we want to debug it, so we need to capture it whenever we call do KNN. So this, yeah, oh my god, I have a troll here. Yeah. Okay, let's ignore Hanso hack. So okay, so here we call Kden. So we need to capture the filter. So I'm going to call this TMP filter as every other variable here, and this is going to be filter. Hopefully it's not a problem to use this on the so this filter value, we want it yeah, we don't want to plot it always, so there's no need. So it's always going to be an A unless we have this. Hi Brian. So what I'm trying to do is to the KNN wrapper from lastguru. uses KNN sum to decide if you have to go long or if you have to go short. Okay. Let me see. Let me report this. Okay. Behave, Han Sok. Behave, or you will be banned. Okay, so I was trying to explain to Brian. So this is a KNN wrapper, okay? So the KNN wrapper uses this function KNN sum, which outputs sum of some values here, which are related to the distance of the points, which I am not very sure what it means, but yeah. And then this is saved into filter. That's how you compare it with the skew to know if you are going long or if you are going short. So this has a behavior in the new script which uses the library. However, in the old script which I have here, it has another behavior. It doesn't say go long, go short at the same time as the script with the library. So that's what I want to debug. So first of all, I'm going to debug the filter value from the library. Okay. Yeah, so basically what I do is I get a new variable here so that I can return it here, and then in the global scope I am going to be able to capture it here thanks to this global variable filter. So the idea is that filter, it's going to capture this value here, which is returned from the wrapper. Later on, once we have filter, we can just plot it so that we can debug this. So let's try this, the first thing, to see if we manage to plot filter, okay, with the new script. And then we will deal with the old script. Base type of calculation, go long or short. Yeah, that's the idea. So if you've got an skew, so if the filter is bigger than 1, I think the skew is wait a moment, the skew was 2. I am always, yeah, so the difference I think is 2. So the idea is we will see when we see the filters, but the idea is that you save 1 and -1 related to the points, okay, and then you have got this filter. Maybe we can plot, maybe we can show the filter so that we can check all of this, and I maybe explain a bit better. So yeah, so the new code is here. Let's try to plot this. Skew, yeah, that's the skew. I mean, skew is a distance, but lastguru rename it to the skew, and it's a bit complex. Okay, so now if you go to the data window, we can check the filter value. So every time you are here, you get a filter. So filter is +1, -1. Okay, so skew is let me check, but I'm quite confident that the skew is 2. So this is the distance. That's why I have to rewrite everything so that it makes sense, because right now all of the functions are. So this is the distance. So this is the third parameter of the function, and the third parameter of the function is skew. Okay, so we need 2. So if we go to the first time this is run, which is 1st of January, because I have forced it to start on 1st of January. If we go here and we replay, you will be able to understand a bit more what is happening, maybe with 3x. I am not sure. Okay, so here you have the first candles here, and if you take a look at the data windows, you can see how okay, the first time the filter is 0 because it doesn't know what advice to give. The next time it's 1, so it has this 1 filter. But let's keep going on, and you will see how we are going to have a piece of advice. Okay, here it is. So we have a piece of advice here, which is the filter is 2. So as we have that filter must be equal or greater than the skew to go long, it goes long. Okay, and the idea is that let me show you. Let me show you what's a bit the idea of this strategy. Yeah, okay. Hopefully, yeah, this is in. Where the hell is the image? Okay. So take a look. Take a look here. So these are short values. So this is -1. I mean, these are associated with category 1, which is -1, and these are associated with category B, which is B. So let me write it down because it's a bit complex. But once you understand this, it's quite nice. So let me try to make an explanation here, because it's nice to know what the hell we are doing with all of this. And maybe we can do this smaller. I'm not sure how to draw this so that it's properly. Okay, let's move this so that it's above the other ones. So the idea is the following one. It's not exactly what the original script does, but the idea is good at long, then I save 1. Good at short, then save -1. Okay, so all the green points which represent ADX and MFME, which is another indicator based on RSI, okay, are similar. That's the idea. all the green points got at long safe 1. So this is green points, and these are blue points. Okay, and so all the blue points, which again represents ADX and FMI values, are similar. Okay, so what does KNN do? You can give KNN a point, so it's ADX plus FMI value, and it can tell you if it's more likely to be in the green points category or in the blue points category. Okay, so the idea is that not sure about this. So the idea is that 0 means I don't know. So this is the filter. Okay, not sure about this filter meaning. So the idea is that KNN, with their own calculus, it replies with different filter values. Okay, filter value meaning, filter meaning. I don't know where to put this point. 1 is okay, it seems a green point. 2, it's I am quite sure it's a green point, and then I guess that you can have 3, 2.5, 2. I mean, I am too sure that it's a green point. Okay, and if you go to the other side, it's the other way around. You know what I mean? Because we have matched the short positions. I mean, good at the short position as -1. So when you go to the other side, it's the other way around. So I am sure that this is a blue point. I am sure that this is a blue point. And now I am quite sure that this is a blue point. So the skew, it's quite easy to understand. Okay, let's remove this. The skew is quite easy to understand once you have this in the head. Okay, so the skew is like filter inside of the filter to know if you want to go long or not. So this is it. So is the filter greater than 2? Because I want to make sure that I am okay. You know, 1 is good, but it's not enough for me. I want 2 or 2.2 or 2.5 or 3 or whatever. I do not want 1 or 1.5 because I am not sure enough that this is a green point, that this is a good at long point, which is a combination of ADX and FMI. Okay, that's why you have this. The old script works the same way. You have a distance instead of skew. However, it doesn't work better. ADX and FMI value are not similar values. Yeah, but you don't care about that because they are similar. Okay, let me show you the points. Okay, let me try to draw here, even if this is not so. Okay, line 3x. So let's suppose that this goes from okay, let's suppose that one of the scales goes from 0 to 100 and the other one goes from 0 to 1. So I don't care too much if they are okay or not. Can we do some points? So our eraser. Can I draw? Okay, maybe here I can draw some arrows or something. Let me see. Different time frames, value and condition are different. Yeah, but we are working in a single time frame. We are not working on different time frames. Okay, never mind. Let's do the points with rectangles. So you have a point here. You can have another point here. Okay. Okay, maybe. Okay, you can have another point here, and these are the blue points. Let's say that these are the blue points. Let me. Well, I mean, what the hell? Like this. So these are the blue points. So it means, okay, now we're going to have the green points down here, maybe. I mean, I have no idea if this makes sense or not, but this is because that way you can understand what this is all about. Okay, maybe here. So these are this is let's say that this is good for short. Okay, here, and let's assume that where the hell are you? Here. Let's assume that these are good for long. Okay. So what this means is that even if you have 101 here, okay, so ADX, so yeah, so let's suppose that this is ADX, which I know it's from from 0 to 100. That's right. But I am not sure if MFI is from if it's 100 or if it's 1. But the idea is that even if it's the case, even if you have here this, which okay, let's do, I don't want to, let's do this stupid arrow here with different lines, even if you could have a better thing. Even if you have here ADX, okay, let me see. Here you could have ADX, I don't know, 15 and FMI 08, let's say. Okay. Even if you have this, it doesn't matter if the values from ADX and FMI are different. What matters is the distance of the points. So what happens is that the KNN is going to get a new point, which we're going to paint in orange. So the question is this new point similar to good for long points. That's the idea. That's the only thing you have to ask yourself. Okay, so that's it. Look at that. That's it. Okay, let me see. Even on the same time frame, FMI and ADX value are different because when you see the FMI and ADX indicator source code, they use close price to plot, which means without price, no indicator will be plotted. Even if plotted, that is will not be effective, but in your script is not inserted, so it's less effective. What is not as effective? They use close price to plot. Why do you say that it's not effective? And why do you say that it's not inserted? So if we take a look at the new script, we can check where the hell this is used. So fortunately, as a source, I think this is using open, although I'm not sure. So here in the script you can see how where the hell are we? Wait a minute. Okay, here you can see ADX and FMI. So this is used. So this ADX is calculated here, and it has some values. It uses change on high, low. I'm not sure what more. If it's using something else as close, because I am not seeing it, but it's using high and low. Okay, and then later on you have this ADX. That's it. And you also have MFI, which is using you have an RSI here, which I mean, what the hell is this? Yeah, so you apply the RSI. Okay, so this is not an RSI. You apply the RSI to FMI and FM down, which is using the volume and the change on the price. I mean, this is another way of calling the price. Instead of using close, you can use OHLC4, which is all of these values: open, high, low, close, summed and divided by 4. Okay, so yes, you are not using close, you are not using the price as everybody knows close is the price, but you are using OHLC4, and you are I mean, this is 100, and here ADX is also based on 100. So actually what we have here is that this is 100 too, but it doesn't mean that the values from ADX and MFI are going to be similar. This is not what KNN does. What KNN does is it takes a look at this at this point here, which is maybe MFI 0.7, so if MFI, okay, let's modify this so that it's 80, okay, 80.0. Look at that. So what KNN does is it tells you if it's closer to good for long or if it's closer for good for short. And what I want you to understand is that it doesn't matter if ADX and FMI values are quite different between them. What it's useful is that the points are similar, and there is some settings that you have to tweak because sometimes they don't seem similar, and there's why you have the KNN setting for this. Okay, but this is the idea. Okay, let's save this somewhere. Save chart, and let's search. This is going to be KNN explanation. Not sure if we can. Yeah, okay. Copy link to the short image. Okay, so this is going to be KNN explanation, so if anyone wants to use it, it's here. Okay, nice that I can post the picture on the trading view chat. Let's do the same thing in YouTube because it's free. Okay, so now I'm going to move on. Priya, I'm going to move on, and I'm going to debug this stuff. Okay, so the idea is that once you've got more data, you know that this is 0, and then this is -1. Here is -1, and this is +1, and if you are here, this is +2. And this is -2, so you kind of start around here. When you have 1 and -1, you know that this is 0, and then you move around. That's a bit or more or less what the KNN is. So give me 5 minutes, please. Okay, so let's go on. Yeah, let's remove all of this. I'm not sure how to multi-select many stuff. Let's remove all of this. Maybe if I undo, I don't know if it's worth it. Oh, I need to use the point. Yeah, that makes sense. Okay, look at me painting some stuff here. Okay, so now let's work on finding out filter, but in the old code. Although, first of all, let me make a copy of the proof code so that later on I can understand what the hell have I done. So copy 13, this is the back filter. Okay, so now we are going to debug the old code, which should be something similar. If we want to plot the filter, let's see how easy it's to plot the filter here. Okay, so the filter is here, and yeah, okay, so I should be able to do this like this, and that's it. Let me copy the let me just copy the file that I have just created, and because this is a good code, even if you don't think so. So this is debug filter. Okay, so now we should be able to copy and paste the old code, and back in the chart I can modify the old code source code and put the new one. By the way, I did not tell you anything. How did you know that I was streaming? Brian. Okay, yeah, so now we have this filter thing, which okay, so let's go back here maybe. So the filter, what? The filter is 0, but on the first time is 1, and then we've got 2. So I wonder if this is related to how the matrix is created originally. Because what happens is that we have the old data from the other one. So here we have 0 and 1, and here we have 1 and 2, and then we have 2 and 3, and yeah. So that means that the old code is running this first somehow, and that makes sense, but I mean, I do not see it. Oh, Oh, look at that. So here we have a store, and then we get the advice. Let's take a look at the wrapper and see what the hell the wrapper does. Can we take a look at the wrapper? Okay, so the wrapper is here. So the wrapper has this new matrix. Okay. So if boolean is true, which was what we do, and we store it, this is what we do, then this is saved here, and then this is run. I am not sure that this is being bonified. I am not sure at all. Because why KNN sum would give us these results? So here you can see how this KNN matrix, I mean, we do to string, so it's the same thing. KNN sum. So KNN sum is not supposed to modify the matrix, it's just getting some value from there. Okay, let me show you in the bottom buffer how this works. So in the bottom buffer, what we have is this buffer, which is exactly the same thing. So you've got KNN, which is the matrix with the values, feature 1, which is ADX, and feature 2, which is MFI. Okay, and then you have K, which is used, well, which is used to know how many values you have here. Wait a minute, why don't you have? Yeah, okay, no, KNN is not the matrix, but this K value here, which is the number of neighbors that you want. So if you go up here with you check this same file, this same function, you can see how it's similar but not quite. So here you can see how there's a difference, which is this returns 0 if the rows for the matrix are 0, but this is never going to happen because we make sure to start the variable with one row of zeros, because that's how the old script worked. Okay, so here we can get rid of this, and we can focus ourselves in this function here to see what the hell is different. Okay, because that's something that so KNN slice, so this is a vector, and here you also have a vector, which is this is slice here. So here you can see how you have the distance, and wait a moment, KNN get, and this is the K, yeah, KNN get. The first input is a distance, the second input is an array copy. Hi Hans. Thank you. Yeah. Enjoy yourself in my GitHub page. Links my previous pages. Okay, so I am not quite a guru, but I know a bit, yes. Okay, so I am not sure what's the problem, and I think it's related to this array copy and so on. So we need to debug this, because otherwise I'm going to be here all of the time. So maybe we can work out KNN distance, and then we can work from there to see if there is a difference in the rest of the stuff. So here you have KNN distance, okay? So let's debug this part so that I can return it. Okay, so let's start with the improved version. So the improved version, we can call this here, and we can say, let me see, we can say, let me see if this makes sense or not. So let's open here, let's open the new script on the bottom buffer, so that this is easier to do. So here I have the line that I want to get the value, which is KNN distance. Let's try to translate everything to the right place. So I am not afraid of using this, because I know that distance hash seriously, you don't. Why wouldn't you return just a number and that's it? So do the array sum here instead of outside here. That's interesting. Okay, so let me check what this is all about. So matrix float KNN, this is the original matrix with all of the data. So this is KNN distance. This is the first argument of KNN sum. So let's use it. The first argument of KNN sum is this one here. Then I think this P1 and P2 are the two features. So as you can see, it's the same variable name as the first feature and the second feature. And here they are, P1 and P2. So this is feature 1 and feature 2. Nice. So now, as I cannot define a variable here and then get it from below, because that's not make sense, because it's created here, what I'm going to do is I'm going to create, I mean, the distance is an array, isn't it? Yeah. Let's get the array. Oh, but then I don't want to return an array. Okay, let's do here my slice. Let's have this here. Let's do this here, which is going to be Let me see. This is going to be my slide length TMP, let's say. So here you can see, you can say that this is I mean my slice and my slice. Okay, so my slice length, it's going to be 0, it's going to be an A. So that way, if it does, well, yeah, it's going to be an A. And now here I can capture this. KNN distance. Yeah, we can maybe get the first of the values. Well, I don't know. In any case, my slice length is going to be this thing here. And now I should be able to get this value out of the function, which of course we will need to capture later down here in the global scope where we call all of this. So here you have this new variable which we're going to call my slide. Oh my god, how many variables do we have to create, because this is not enough. So my slide length, yeah, let's do it. So this is a float. Let's not use this. And this is going to be here as, please get me this value here. Now I should be able to plot this my slide length, which I guess will be different than the one from the old code. Okay, so let's try this new code, because we don't want to be here all the night. So let's try this. Yeah, so now we should have the array length, which you can see how the array length is 2. I mean, it's not actually the array, no, sorry, my slide length is 122, and then here is 105. Okay, so I guess that this is the distance to the different values. I am not very sure what this means. However, I want to compare it to the old code. So let me copy first the new code to know that I have the back. So this is the old code, I mean the new code. Copy 14, and this is the back slice length. I mean, I want to work with GIT, because otherwise this is a lot of confusing with so many copies. Okay, let's work with what's the name, with the old code. So what we want to plot is this thing here, which is a slice length. Let's go to the old code. So basically the result of calling this function is what we want to plot. Wait a minute. This is filter? No, it's not. Okay, yeah. So what we want to plot is KNN distance P1, P2. That's it. And KN distance is using this stuff. And I guess that, okay, it uses this KNN1, KNN2. It has this distance here. Wait a moment, this distance. Okay, yeah, but it's not in capital letters. Okay, so what we want. Okay, let me see. Array new float. Then you return this. Okay, let me check the new code because now I do not understand what the hell are we doing here. So this KNN sum, so I guess that this was not in the old code because I am not getting this. So you've got the distance, but then here there's no. Okay, so we've got the distance with. Wait a second. So we've got this distance. So what I'm doing here is getting this same distance, which are 3 different values, and then I am making a sum. So this is from me. So what I want to do here is to call KNN distance manually and then sum its contents. That's what I want to do. So I want to do this at the same level here, I guess. So I want to have ADX and FMI as an input. Okay. So KNN distance. Yeah, so now I have this distance which I have to sum thanks to something. What the hell are you? Array sum. Yeah, that's right. So array sum of this distance should be fine. So this is, so we want to plot this as my slice length. This is the old code. Let's put all the here just in case. We don't want this. Let's copy the rest of it here. Okay, so this is the old code. Nice. Let's try and see if this works at all, because I am not sure. Maybe I need some more stuff. So the old code is here. Let's try to update this. Cannot argument color. Series color is affected. Name location. Plot. Okay, it's plot char, isn't it? I have done this without copy and paste, and it was wrong. That's why copy and paste is so a powerful tool. Okay. Oh no. Oh yeah, we have no traits. So let's take a look here. My slide length, this is new code and this is the old code. Let's see what values we have. Okay, look at that. My slide length is the same value here. And here we have the same value. What do you know? Let's go on. I want to know what happens when we have 6, 6, different values. I mean, the array is 6 length. Okay, so here we have 6 length, and yeah, we can check maybe here. My slice length is 92.6. Filter is different, but my slice length is 92.6. Okay, let's go back here. Okay, let me make a copy of this last change for the old code, so that I have this properly done. So this is 07, the back slice length. Okay, so let's take a look at the rest of the function here. So on the top we have the new code. So this is using KNN distance. Let's take a look at this KNN sum to see what's happening here. So KNN distance is always the same thing. So what's going to be different here is this KNN get staff. Distance. So KNN get. Okay, let's open the new script on the bottom too, so that I can take a look at all of this. So here we have KNN sum, okay, and I want to take a look not at KNN distance, which we know it's the same thing. I want to understand what this function does. Create a distance array from the 2 given parameters. No, not this. Wait, this one? No, KNN get. Okay, yeah. So KNN get, let's see what it does different in the old code and in the new code, because that's what probably is this is what probably is wrong here. Let's try to understand. Get neighbors by getting k results with the smallest distance. K results. So this is the k value that we have as an input, which I think it's 5. Let me show you. As an input we have k and nearest neighbors. Oh, 45. Okay, then it's 45. 5, it's another thing. So here you have you get the 45 results with the smallest distance, and it gives you a value. So this is returning an array, if I'm not mistaken. So now an array is sliced from matrix, I guess, but this is an array. So here KNN get, actually what it's returning is an array. That makes sense, because this is an array, and that later on you apply array sum here. So this returns an array. KNN returns an array. Okay. So the first argument is the distance. Okay, that's what we have seen before, that it's always the same value in the new and in the old script. So this distance is added here in a temporary matrix. Yeah, that's right. This is added in a temporary matrix. So you add the 45 results here, I guess. Wait a minute. Okay, results. Okay, yeah, I mean, you get the value from... Where the hell do you get the value here? Wait a moment. So we've got the distance, that's okay. And here we have the result. What the hell? So this result array, this result actually is this thing here, which is get me from the matrix which has data wait a second. From the matrix which has data, return me 3 column. So 3 column is the third column is the one that has 1 and -1, if I'm not mistaken. So this column then what the hell is this doing here? You've got this, then you sort it by the first column, which is the distance. You get, wait a minute. You get the first of the columns. Okay, and then you get the minimum between this array. But in any case, here we have this matrix column KNN3, which is rather suspicious. I think that's what we want to take a look at, to see what the hell is here. Okay, I think we want to debug this because otherwise... So let me write this down. Try to debug. So this is more debug. Okay. So matrix call. I want to check down here. What the hell is this? Matrix call. Okay, so I want to debug this, but down here I want to check how I have done this. So I have this to a string, I have done it here. Okay, so I can do this and have another one for this matrix call. So this matrix call is using this KNN. This KNN data. Okay. So this KNN data I mean, I don't know why this is a problem, but let's debug this. So we have this KNN, and so this KNN is used here, and it's the one here, KNN M. So let's just use it here. Look at that. So basically what I want to do is do something like this. So KNN give me the third column, okay? Then convert this to a string, and finally save it like matrix call 3 so that I can return it. Now I should be able to get this here, and on the bottom I should be able to plot this stuff once I get it. So this is matrix call 3 TMP. So once again we should have this line here, because we cannot do this better with all what we have here. So matrix call 3, and up here I should have a float. No, this is a string. So this is a string which I'm going to define as an empty string by default. And yeah, so now I'm going to plot this into a label, because otherwise this is not going to be right. So maybe I can use my label here and matrix str. Yeah, so what to print, it's going to be this thing. Damn it, it's going to be matrix str plus matrix call 3 plus an enter plus this, and this is going to be used here. Hopefully this makes sense and it does not explode. Let's copy and paste everything here. Okay, we want to edit the new code. That's it. Let's save this and let's see what happens. Mismatch input something 141. So I guess, yeah, this needs another parenthesis here. Let's try this again. Look at that, 16,000. Now you would like to buy Bitcoin at 16,000 and it's quite big. Okay, so now we have this new matrix column 3, which you can see that has 6 values: 1 1 -1 -1 1 1. Okay, and that makes sense because it's the values that we have here: 1 1 -1 1. Yeah, -1 1 1. So I guess that all of these values match because that's what you have here. The third column is this, I mean not the third one but the fourth. Yes, index 0, index 1, index 2. So the fourth column, which has index 3, is shown here. So I guess that the old code is right because we are just plotting this, so I don't think this is wrong. I do not think this is wrong. So what we are left width is, let me see, this k stuff, because KNN get is different, isn't it? Because the slice, so we have already plot the slice here, isn't it? So here we have this slice with this distance. What the hell was this? Yeah, so we have already plotted this filter, which is what's different is the filter. Oh, wait a minute, we have the same filter. Let me check this again. I think I'm doing something wrong. Do we have the same filter values here? Filter 2, filter 3. No, we don't have the same values. That's why we are checking what happens in KNN sum. Okay, so we have managed to check that this is the same thing. I think this is the same thing. So what should be changing, the change should be in KNN get itself. So KNN get itself is here. Okay. So that's why I guess that I was debugging this column 3, because it's used as an input. I think it's result here, isn't it? It's KNN get, you have the distance, and then you have this as an input. So let's check the old code for this KNN get and try to understand why this is not working. Okay, so the old code KNN get. So let's try to find something similar. So KNN get should be KNN get. So we have this here. Okay, so we have a distance. We have this result, then K. So assuming we have the same inputs, which is right, we have the distance. Have we plot the distance? We have, isn't it? Yes, we have plot the distance here. Okay, so we have this distance as the first argument, and here is the first argument, so this is the same thing. And we have this result, which is this copy. So this is copy of KNNR. So KNNR is supposed to be the latest of the arrays, which is the result. Okay. Wait, this is supposed to be the last column, and that's what I have here when I plot the last column is KNNR. So I get the row, I get 0 first and so on. So let me see what the hell we are doing here. Where the hell I can? So you are copying. You have a copy of KNNR. Because KNNR, you have a copy, okay. Let's take a look at this KNN get array. Yeah, okay. First argument, second argument k. Let's try and check everything here. So the first argument, which is the distance, here it does a copy so that it can work with it, so that it can sort it. Okay. So here you have a sort of the distance because it's array 1, and here you have a sort of the matrix. You have a sort of the matrix thanks to the first column, which is the distance. So we are also sorting the result, which I think it makes sense. Although let's see what happens later. Okay, so once you have this sorted array, then you've gotten slice, and you get the minimum from this k array size, which is this thing here. So this slice is the one from here. Okay. However, I happen to have some problems here because this is not here, isn't it? And there is not maximum value. Okay, let's try and check the second result. So the second result is array 2. What the hell? So here you can see how the data from result on the new code is pushed into the second column. Of this temporary matrix, distance and result. Add column, distance and result. Okay. Here we have this array which is sorted. Yeah, look at that. This array is sorted, but here we are sorting all of the matrix, because matrix sort is using this to sort everything, but it's sorting because this column, I mean, if we take a look at matrix sort, if we take a look at that, we can understand. This function rearrange the rows in this matrix following the orders of the variables in this column. Okay, so it's not the same thing as it's happening in the old code, because in the old code this is working only with the array of distance. It's not what's the name? It's not making an order of the results unless it's done here somehow. Let's take a look. What the hell is this all about? So array 2. So array 2 Array 2 is what the hell is this? So this is the damn it, this is the difference. The difference. This is what I have to ask lastguru, so that it explains why the new code is the right one and the old one is not the right one, because I'm not sure what the hell is doing here. But let's take a bigger look here. So yeah, okay, so you have a maximum which is not used here. You have a maximum of this slice here. So this is used to know which is the maximum. So as long as the value that we have here is less than this, you push it onto the new array and you return it. So instead of doing this here, we've gotten a slice of this new variable, which is the second column, which is the result. Yeah, which is the result from here. So I think that the difference is that one of the arrays is ordered and the other one it's not ordered, because that's the only thing that makes sense to me. So why do you want to order this array anyway? So that you get the neighbors by getting the k as smallest distances. Okay, so the k distances are here. So yeah, so that makes sense. So you get a slice which is from this array, and it's from 0 to a given size. So the given size is either k, because the array size is bigger than k, or is the array size, which can be 1, 2. So basically here what you get is a slice from the slice, yeah, the slice of k. You've got the k values here. Then you get the maximum, so that, yeah, so array 1 wait a minute, this is not right. Yeah, so you're actually looping this array, but what you want to do here is you want to loop this array instead, because it's going to be easier. You just return what you want, because here what you are doing is you are checking the array 1 values, which are the distance. You are checking the distance and see if the distance is smaller than the maximum distance here. This is 5 minutes, because that's how the original one is doing. Let me link you to the original script. Where the hell I have the... I mean, I want to change it for with 1 hour because I prefer 1 hour, but you know, the original script from lastguru, what I always call old code, BTC 5 minutes, time frame 5 minutes, and copy and paste. Okay, so yeah, I should probably quote this message. Let's copy and paste this on the other chat too. Okay, so yeah, so I have answered the question, and so what I was trying to understand is this. So it's the K smallest, that's KNN use trend. Not that I know. I mean, you don't use trend per se. Trend can be a feature. So if you know how, if you know how to give trend, if you can assign trend a number, then you can do the same thing as ADX and FMI, so that you can use it here. Okay, so yeah, so this is getting this is getting the smallest distances. However, the smallest distance values, so this is getting the value from R2, which is the result. That's why we've got this slice. Yeah. Huh. Filter KNN with trend, it will cut picture. Yeah, I mean, you can do it. I have my Zignaly template, my record Zignaly template has it. I mean, it's nothing too complex to do. Going to show you quite quick. So I have this. Maybe I can show you in TradingView, which is going to be. It's going to be easier to show what I mean. So maybe the one here. I mean, no, this is very old. Yeah, maybe this one here. So here you can see on the settings that they have. Where the hell are you? Enforce higher time frame trend, so I can choose here if I want to use the same chart time frame or 1 day or whatever. If I want to enforce this, so I have the fast MA with these values. I can choose whatever I want and whatever I want here. So when this crosses over to the top, I enforce the trend to be one thing, and if it goes to the downside, I mean, if it grows, if you cross over, then you only do long trades. If it cross downs, then you only do short trades. And this is what I'm going to use in the end as a template in order to test this. So I will be able to turn this on or off to test if it's worth to have the trend to say we want to go up, or we want to long, or we want to short. Okay, so there's no problem with that. Okay, let's go back here. Let's go back here. I have another stream where I have this. So in YouTube you can find the latest stream about Zignaly library profit sharing 2.0, and you have there the template linked into the video description if you want to test it. But yeah, you need to put some conditions so that it works. Anyway, let's keep going on. So I think there's a problem here on how this is done, how this loop is doing stuff versus what's happening here. Now more or less I understand what's the difference, but I'm a bit confused if you ask me, because yeah. Wait a minute. 0, 0, 0. This is an empty one, isn't it? Let me check if this is an empty stream, an empty matrix. Rows, columns, initial value. Yeah, okay. So this is an empty matrix. So here you add the distance, you add the result. And you can also help me and tell me how to know if the trend goes up or down. What's the better way of doing that? You can help me another day, explain to me what the hell trend means to you, because maybe it's not moving average crossing, but something else. Okay, so we have a problem here because KNN get. Yeah, so this is returning different stuff because it's not doing the same thing. So the code down here makes sense, which is please get all of the array 1 values here. Wait a second. Get all the array values here, which are less than M, which is the maximum here. Smallest distances. Yeah, I see why this is a bug. I see. Array size. Okay, so these are distances, and here you have the values. Okay, so you get the values from here and from here because these values are not modified. However, I have my suspicion that this changes the array. I mean, no, it does not change it because we have array.copy, so it should not be changing this. Okay, let's try again. So we have this slice, which means give me the first k values from this array. Give me the first of them. K as smallest distances. As smallest distances. Oh yeah, so we get the first ones. And I didn't modify the script, the original script at all, regarding those values. Okay. So yeah, this makes sense. So you get source, same thing. Source is open to the full value. Okay, so SS. I mean source. I mean source for the KNN stuff. Yeah. Okay, so this SS is the array slice. Yeah. So we get the maximum here, the maximum value. I mean, what you want to ensure is that array.max. What you want to ensure is that the resultant array is not bigger than this thing here, which is a slice, because yeah, get the neighbors, but get indicate smallest distance from the distance array. So even if you have so many here, you only get the ones. Yeah, this code is not right. This code is not right, because you don't want to use this, you just want to use what the hell? How the hell would you do this properly? Yeah, so this is the maximum. But here you don't. Array size R, matrix call 1. Yeah, I don't think the code here is right, because yeah, I mean, it's much better what we have here, which is just order everything together, and then once it's ordered, because it's get the neighbors by getting k results with the smallest distances. It's much better to just sort this and then get the k results, which is either the array size. Wait a moment. Either k. Wait a moment. This is not right. K results. array slice, k results, k results, k results. So if the array, so array slice, here's there is a back, here there is a back. I know it. I know it. That's why maybe there's a back after all in the new library. Okay. Let me show you what I think it's the back here. What the hell is array.slice? I'm going to show you. Array.slice is index from, index to. So you've got the array to slice, the index from which you want to slice, and the index to where you want to slice. So the first one is 0. And then you say array size -1, which is the maximum. So if the array size is 10, you're going to query index 9. Okay? However, you're going to query index 9. However, if you say k to 5, you are not going to get 5 results. You're going to get 6 results. So this needs to be k -1. However, if I do this, then what's gonna happen is that it's going to be different, because if you take a look at the comparison that we have right now, we have the same exact values. So I mean, it's a book, but I am not sure about this. So if you want 5, if you want 5 results, you want from 0 to 4. So this should be like this. But yeah. yeah. Okay. I mean, I don't think this is going to... Wait a moment. So this is K. What the hell is used here? K, array size -1. Oh, look at that. Look at that. Look at that. Look at that. We don't have -1 here. Yeah. Why the hell does this not explode? Because we add stuff later on, maybe. Yeah, because K is 5, even if... Because K is 5, even if the array is 6. That's why it does not explode. So this is quite interesting. So I think we might be able to do here something. So possible book new code and possible bug to old code. So in the old code we should be using array size -1 like this, and then probably we should be using. Also k minus 1. Okay, but right now I don't want to fix this k. I want to fix this minus 1. So let's go back here. So this is the new code, and down here we have this thing here, which I'm going to comment because, I mean, why not? So this, wait, here, this should be minus 1, because otherwise you're going, oh wait, this is not going to do anything, because so array size minus 1 is 5, which is 5, so this is not going to change anything. So there's no need to test this. I mean, it's a bug, but only if you don't specify this k. So damn it. I mean, yes, we could play with this, but it's the same thing as here, I guess. Yeah, but this code is not very good. Well, this array here, it should be something like using the indexes from the other arrays. So let me see. Yeah, this is not right. This code is not right. Array slice SS has the values but not the indexes. That's not a good thing to have here. Although so we should be able to get this length. So the question is, when do you know that you can do this? And you know if this is less or equal than the maximum, because the maximum, but the problem is that the maximum might be different values, and that's why everything is wrong here. Yeah. Yeah, that's the problem is here. That it makes sense. It makes sense. Problem is here. So let's assume you have something like 5, 7, 8, 9, 10. So this is okay, but let's assume you have something like maximum is 9. Okay, let's assume you have this 9, 9, 9, 9, 9. Maximum is 9. So you decided to have only 5 numbers, so you get these 5 numbers. And here you also have, you have decided to have only 5 numbers, but you output all of this here. Okay, so and you output this thing here. Here's the problem. You output all of this here. So yeah, so this old code is wrong. I mean, it's wrong. It's not well done. Not okay. Okay, because if you've got this maximum, then you are done. So how to fix this thing here? Okay, let me make a copy. The back slice length. Let me make a copy of these 2 files, please, so that I can make the change. So this is going to be copy 15. Prep. KNN get fix. And let's also copy the old code. So copy 08 and say something like KNN get fix. Okay, so this is nice. So now I'm going to fix this properly. Okay? So you will ask myself, how do you do that? Because let me see. So the new code, it's doing a slice of what it needs from the first column with the data. That's what we are going to do. A slice of the correct value. So the way of doing that is taking a look at what's the array length here. So the array length from size, it's size, it's not length. So the array size is whatever. Okay. So now what I do is slice out array length, it's going to be 0, and each time you push anything, this is going to be +1. Okay, then finally if whatever the reason is, this is greater or equal than the size length, the size length. So if this is 1, it's going to go out from the for loop, and we are going to have the array. Okay, so now let's copy this on the old code. I'm wondering, maybe this was already proposed by someone else in the old code comments and I have overlooked it. Risk management, something. No, this is not it. Okay, let's go back here, the old code. Let's see if we have managed. Okay, let's remove replay. So I guess that What the hell? My slice length 92.6. This was the same thing. And the filter, and you can see here that the filter now, it's every time we output something, the filter, I mean, it's not always the same thing, so probably there's something wrong somewhere. Okay, so this is the old code and the new code. Wait a moment. Look at that. So we have managed to fix the old code because it had to be fixed so that it works as the new code, okay? So basically that's the fix. So let me write this down. So this is old code final fix. I mean, finally. So we should be able to show this to yeah. Okay. So I'm seeing that some values are not equal. Let me check, because I am not sure about this. So my slide length is the same thing, and the filter is always the same thing. However, apparently one of the first traits, you didn't have anything. So let's go to the past. Let's check what happens here, because I want to check what happens with the filter values. Because maybe it's nothing, maybe it's something. So the filter value is the advice that KNN gives us. Okay, so thank you for the like, Hans, I guess. So yeah, matrix column, yeah, we don't care about this. Let's check the filter. Filter 0. Yeah, that's right. What happens here? Filter 1, filter 1. Okay. So apparently we have the same exact advice, and I don't know why I thought that there were different values before. But if you get into the place where you've got the advice, it's always the same thing, and that it makes sense, because otherwise. Okay, look at that. The old code has as a filter 3, and the new code has as a filter 1. So it's not working the same way. Why the hell is this? So the matrix is the same thing, as you can see. However, the filter is not the same one. What the hell? So we have managed training view IP4. I got to you because of training. Yeah, I mean, it's my library. You can find it on my you can find it on my my page and so on. I'm going to send you an URL so that you can take a look, but it's also in GitHub. There's this so what I'm going to show you is the old version, but you have the new versions. I mean, what the hell is this? I mean, yeah, this is for the old version, but it should get you on. Then when you copy the URL to YouTube, because YouTube chat, because I don't know if it's right to copy it on TradingView. So if you go into my profile, you can check. If you go to my profile, let me see. And scripts. This is private, but you know, this Zignaly to beta, you have it on the GitHub, and you have some stuff. And if you go into the Zignaly Discord, you can get help there in the pinned message, which has all my resources. But the thing is that there is a public, here it is, Zignaly tutorial. So you should be able to get Zignaly tutorial from my public profile, and you've got everything explained on how you interact from TradingView to Zignaly. You've got here all of the explanation once again in the what's the name? All of the explanation on the source code. You've got a lot of inputs and a lot of code, and yeah. So Zignaly tutorial is on my profile. You can take a look at it if you are interested on the how to integrate with Zignaly. But I recommend you to go into the Zignaly Discord so that you can get all the pinned messages on how to deal with all of this. This is profit sharing 1.0, but it will help you to understand what to do profit sharing 2.0, because I have the version for this too. Okay, let's not talk so much about Zignaly. Let's go back to understand what the hell is happening with this filter thing, that it's returning different values for filter. So yeah, I mean, so we have managed to fix this, but even then I wonder if there's something wrong in my logic. So if the size gets to 10 because this has 10, then we break. So if the array only has one element, this is going to be 1, and then we break. That's right. What about this I here? Yeah, so we don't need this to be minus equal m, or do we? Yeah, I mean, the condition is that yeah, I mean, the problem is with this maximum is here, the problem is here. This is not right. We need something else to have this maximum. That's why we have a different filter. But then later on, I guess that this fixes myself. This fixes itself. Yeah. Okay, let's check my video about Zignaly and crossing EMA's demo. I think it's better for a new way. Okay, so yeah, this is the problem. There's no way around this. I mean, what you have to do is do this into matrix, and then you have to order the matrix, and that's it. That's the only way you can fix this. Yeah, final fix, almost final fix. I mean, there's no reason for trying to fix whatever we have. So this is the another old code back is, yeah, we should not rely on M as a maximum, because now we have the same orders, the same entries, the same exits, but you know, we have the same what's the name? We have the same traits, but the filter result is not the same one. But now I know that that I can use the library properly. So now what the hell? Okay, so now I'm going to write down what I want to do here, because otherwise this is getting. So next video work. So we want check if we fixed anything in the library, and make sure to update it if needed. Yeah. Once again, when with the nice variables script, make sure that it works as expected. Then we can integrate with Ruka single data plate with functions inside of the script, not as a library. Finally, try to use 3 variables instead of 2 variables, and try this thing about checking plus 0.16 and from the future. Okay. Hans. Oh, that's interesting. You have like a German name and you come from Trading Latino. I hadn't thought about this. Are you from Argentina? mean, maybe. So yeah, this is what Chile, okay. That's interesting, your name. Okay, nice variable script. Yeah, so this is more or less what I want to do in the next video. I want to take the original script, I want to put there the functions, the nearest variables, nice variables script, then put the library functions again, fix the library functions, and then we can integrate this into the main code. Sure, in the main code. Okay, let's take a look. Maybe I have here what the hell I have fixed here. So this is the old code. So this should probably be fixed by using a matrix. So no need to try to fix it. Okay. Then okay, so this is the old code almost fixed, so that yeah. Okay, so there's a bug here, which I think this needs to be k-1. I have not fixed this, so let me copy and paste this so that I can have it here. So this is fix 1. We want to do this, and then the difference is actually based on the old code being wrong, so there's no need to modify the new code. However, yeah, so we want to fix this so that it works with 5 instead of 6 data. Yeah, and I think that's it. Yeah, I mean, this fix, we are going to have different data probably, but this is the fix that needs to be, this is what needs to be fixed on the new code. And then these 3 variables, then we can do this thing about maybe 3n. Yeah, I mean the KNN script setting is awful because the names are not quite good. So I want to improve that, because what the hell is in SKU? You need a tooltip and so on, you know. So I want to try to use, and then this thing about maybe using more than one, but I'm not sure if I'm going to do it with more than one KNN matrix, so that I can check what happens with 5 bars in a row instead of using 3 n variables, because that's what I want to do. I'm going to What the hell is this? Yeah, maybe I can just remove this so that we can take a look better. So what I want to do basically is I mean, let me see. So here, so I want to check here, and I want to check distance from here. So it's something like that. So here, what did happen 4 bars ago? So this is a good thing because we have 1:3 ratio, so we save it. So we saved the values that we have here, so that later on, if something similar happens, like this thing here, we can go on. We can open a long position. So I want to save this bar, this bar, this bar, this bar, this bar, this bar, or percentages or whatever, so that later on, if we find maybe something like that, I go into the long position, you know. But this one is not right, so you write it like -1. But if it happens that many of them are right, we are going to know it, and we are going to save them into the matrix memory, and that's when we will be able to know more or less if it makes sense to open a long position. So maybe this thing here, which goes up, we can try to save these values somewhere in the matrix. That's the idea that I have to do with all of this. But it means that we need, if we save different matrix in order to check that every one of them is right, or most of them are right, we need to code this with different matrix. That's what I want to do later on, because I prefer to do it like that. Probably there are better machine learning algos for doing that, but you know, so far I'm going with KNN and then going to play with it. So I think this is all for today. Thank you very much, Hans from YouTube, for being here, and thank you very much, Brian from TradingView, for being here. Bye.